This is the beginning of the last material that we will cover. A vector is anything that has a magnitude, which is a size or a length, and direction. A scalar is anything that has only a size. And the easiest way to get a feeling for which is to look at some examples, but we do need some notation. The tail of a vector is the point at which it begins. The head of a vector is the point at which it ends. You can see this little image. Five miles south is a vector because it's an amount and a direction. 5 miles would just be a scalar. And here, 25 miles is a scalar. It doesn't say 25 miles in what direction, just 25 miles. Here, 250 pounds is a scalar because it doesn't say whether it's up, down, sideways. However, weight, 250 pounds weight is mass acted on by gravity, and that is a vector. The English units are a little bit confusing with the pounds mass and pounds weight. In metric units, they're different, and that makes it easier. Volume is a scalar. And I can't think of an example of volume with a distance or direction. 60 miles per hour is a scalar, but 60 miles per hour north, 45 degrees east is a vector. So 60 miles per hour is a speed, where 60 miles per hour north, 45 degrees east is a velocity. Velocity has magnitude and direction. Magnitude is the size or the length. A vector in standard position is a vector where the tail is at the origin, 0, 0. The magnitude of a vector, if the tail is some point P, P sub X, P sub Y, and the head is some point R, R sub X, R sub Y. We use this notation with double bars. It looks like absolute value gone crazy, and it's a little similar, but we call this the magnitude of the vector. PR is R sub X minus P sub X, all squared, plus R sub Y minus P sub Y, all squared, and the square root of that, which you can see is going to be just like the distance formula. So we've got P sub X, R sub X. Let's let this be P sub Y, R sub Y. So that means that point P is in quadrant 1, and point R, let's see, is in quadrant 4. So we would say that PR, the tail is at P, pardon me, the head is at R. That means it's going from P to R. And we illustrate that. Sometimes you see a half arrow, and sometimes you just see a regular little arrow. So this means from P to R. And if we draw a triangle, I can see that this horizontal distance is the distance between P sub x and R sub x. So R sub x minus P sub x. And I can see that the vertical distance is P sub y minus R sub y. And I know from the Pythagorean theorem that the distance of this arrow is going to be, let's call it, we don't want to use R because we've got an R. Let's call it C. We know that C squared is equal to R sub x minus P sub x squared plus P sub y minus R sub y squared. Oh no, we had the wrong order here. But why is it okay? If we're squaring, why does it not matter what order we have?
Because it'll stay the same.
That's right. So here we'd have P sub y squared minus 2 P sub y R sub y plus R sub y squared. So we'll get the same thing regardless of which is first and which is second. And then to find C, we just take the square root. This is a magnitude, a direction, a distance, so it's positive. And that's exactly how we get the magnitude formula. The direction is the angle that the vector makes with the positive x-axis. So here, the angle theta it'll be the same. So the angle theta will be the direction of PR. All right, let's look at two vectors where PR is 3, -1, -1, 2, and SQ is 1, 4, 5, 1. And they want us to sketch the vectors what's the largest? X is 4. And the largest Y is 5. Oh, no, backward. And the smallest looks like -1. Okay, now we can plot everything. So P is 3, -1. R is -1, 2. So PR is that vector. S is 1, 4. Q is 5, 1. So that SQ is the vector going from S to Q. And, oh, we didn't, I missed this. So standard position means that we put, I think I said it, but I didn't really say it much. If the tail is at the origin, then the vector is in standard position. And that allows us to take two vectors that look different, but we think maybe describe the same thing. This allows us to move them to the same place. So the tail of PR, I'm going to move P to the origin. Let's see. P was 3, -1. So I'm going to go up 1 and to the left 3. So up 1 to the left 3. And I'm going to do the same thing with R. R was -1, 2. I want to go left 3 and up 1 so that the new PR, let's see, -4, 3. So PR in standard position is -4, 3, and it ends at -4, 3, and the tail was P. Okay, good. Now let's do the same thing with S. Let's see. S is 1, 4. To move S to the origin, we're going to go 1 space to the left and down 4. And we're going to do the same thing with Q. Q is 5, 1. We're going to go 1 space to the left and down 4 so that we get 4, -3. And now it's possible to see that they are definitely not going to be describing the same event, the same kind of amount. Because SQ is going down and PR is going up. Let's find the magnitude of each. So the magnitude of PR, let's see, R was -1, 3. P is 3, -1. So we get -4 squared, which is 16. Plus 4 squared is 16. This is 16 times 2, and I can write that as 4 times the square root of 2. And now let's find SQ. Let's see. It ends in Q, so let's write down Q first. Q was 5, 1. and S was 1, 4. So we have 5 minus 1 is 4, squared is 16. 1 minus what did I do? Guess I get 3 there. I must have put a wrong number over here somewhere. So let's see. P was 3, negative 1. And R was negative 1, 2. Okay, there we go. So 2 plus 1 is 3. 3 squared is 9. 16 plus 9 is 25. Square root of 25 is 5. Okay, groovy. 1 minus 4 is negative 3. Negative 3 squared is 9. 16 plus 9 is 25. Square root of 25 is 5. So they have the same magnitude, but I can see that SQ is going the opposite, exactly the opposite direction to PR. So they cannot be the same. Two vectors are equal or equivalent when they have the same magnitude and the same direction. So now we're given 3 vectors, PQ, SR, and TU, and we want to see are any of them equal to any others. So let's see. We've got P is negative 5 for Q is 0, negative 2. R is 4, negative 1. RS. S is negative 1, 5. T is negative 1, negative 4. And U is 4, 2. And let's start out by finding all of these magnitudes. We're looking at PQ. So let's see, X coordinate of Q is 0. X coordinate of P is negative 5. Y coordinate of Q is negative 2. Y coordinate of P is 4. Zero minus negative 5 is positive 5. Squared is 25. Negative 2 minus 4 is negative 6. Squared is positive 36. And we get 81. So the magnitude of PQ is 9. Wait, no. 5, 6, 61. Okay, so the magnitude of PQ is just square root of 61. All right, let's look at the magnitude of RS. So let's see, the x coordinate of S is -1. The x coordinate of R is 4. The y coordinate of S is 5. The y coordinate of R is -1. -1 minus 4 is -5. Squared is 25. 5 minus -1 is 5 plus 1, which is 6. 6 squared is 36. And you can see that we're getting the same two numbers. So we again get square root of 61. And now let's find TU. The y coordinate of U is, no, pardon me, the x coordinate of U is 4. The x coordinate of T is -1. The y coordinate of U is 2. The y coordinate of T is -4. Four minus -1 is 4 plus 1, which is 5. 5 squared is 25. 2 minus -4 is 2 plus 4, which is 6. 6 squared is 36. And again, we get square root of 61 for the magnitude of TU. Let's sketch this system. Let's see, we go up to, there's a 4, there's a 4, there's a, okay, so 4. In the y direction, we go up to 5. In the negative x direction, we go to -5. And in the negative y direction, we go down to -4. Okay, groovy. So PQ, let's see, P is -5, 4. And Q is 0, -2. So that PQ is that vector. R is 4, -1. S is -1, 5. So that means that RS is from R to S. Oh, let's go ahead and write these in. This is 4, -1. S is -1, 5. And finally, we're going to sketch PU. P starts at -1, -4. U goes to 4, 2. And we're going from T to U. And I can see, without doing any math to find the angles, that PQ is opposite in direction to RS, and that it looks like PU is actually at right angles with PQ and with SR. The component form of a vector uses this little unit vector. So if the horizontal displacement is little u, or u sub x, and the vertical displacement is u or u sub y, then we can write u in component form as u is equal to, and you see that these are squared off. So u is equal to u sub x, comma, u sub y. So let's look at the three vectors we just drew. PQ, let's see. I'm going to use my drawing because it's bigger. PQ So PQ sub x looks like we're going 5 units, and it's in the positive direction. The y change is 4 plus 2 is 6, and it's negative, so that we would say that PQ is equal to 5 negative 6. And what about SR? Let's see. We start at -1 and we go back to -1. So let's see, wait. We start at 4 and we go back to -1. And in the y direction, we start at -1 and we go up to 5. So -1 plus 5. No, minus 5. Yes, to get the distance. Okay, so we're going positively for y and negatively for x. So we would say that SQ is -5, 6. Because we go up 6 units and we go back 5 units. And what about PU? So T there we go. You have the x displacement is 4 minus -1 is 5, and it's going to be positive. The y displacement is 2 minus -4 or 6, and it's also positive. So we would say that TU is 5, 6. So you can see when we put these in component form that they're all very similar, but none of them are the same. If two vectors are the same, then in component form, we'd have the same number. If a vector is in component form, then we just square the x value and square the y value, take the square root to find the magnitude. And we say that two vectors, u and v, are equivalent or equal only if u sub x, v sub x are the same, and u sub y, v sub y. The negative of a vector u is exactly the opposite. So it's negative u sub x, negative u sub y. U and negative u will have the same magnitude, but obviously opposite direction. We can find the angle between two vectors using the cosine. And the reason we need to use cosine is that we're looking at, we've got values in the first quadrant, and it's an angle in a triangle. So we've got values in the second quadrant. In order to differentiate between angles that are in the first quadrant and those in the second, we can see that the signs of those SINEs, the signs of these numbers are the same. They're both positive, but cosines, we get a positive and a negative. So if the cosine is between 0 and 1, the angle between the two vectors is acute. If -1 is less than the cosine is less than 0, then the angle is obtuse. And of course, if the cosine is -1, it's a straight line. So let's see. So we've got u is 4, -5. V is -4, -5, and PQ. So let's P is -2, 3. Q is 2, -2. And we want to compare PQ with U and with V. So let's find some component, some magnitudes. So I can see that PQ I've got 2 minus -2 squared and -2 minus 3 squared. 5 squared is 25. 4 squared is 16. $41. The magnitude of U is just 4 squared plus -5 squared. And I can see I'm getting the same two numbers. 16 plus 25 is square root of 41. And finally, the magnitude of V is -4 squared plus -5 squared. And we'll get the same two numbers, 16 plus 25. So all three have the same magnitude. Let's find the component form of PQ. And we're starting with P and going to Q. Q is 2, -2. P is -2, 3. Okay, so that is, let's see, Q was 2, -2. P was -2, 3. And we're going from P to Q. So I can see we're going 2 minus -2 in the x direction. And -2 minus 3 in the y direction. So -5 and +4. So that means that PQ is equivalent to, the x direction was 4, the y direction was -5. And now we can easily compare the three vectors. So U was 4, -5. 4, -5 is also PQ. V is -4, -5. So yes, it has the same magnitude, but it's not even in the opposite direction. Let's look at it. So U is 4, -5, 2, 3, 4, 5. V is -4, -5. Okay, now we got it. So U is 4, -5. Whereas V is -4, -5, -4, -5. So we can see that it looks like they're at right angles with one another. We'll next class we'll get to do something called the dot product, which will enable us easily to find the angle between vectors. Well, now let's look at some properties.
Just a reminder, we have about 5 minutes left of class.
Oh, okay. I tell you what then, I don't really want to start this if we can't finish it. So let's pick up at properties of vectors on Monday. And I'll have the notes for dot product also available. And I'm going to stop the video. Are there any questions at all?
I would like to ask a question later.
Oh, okay. You want me to let me stop the video.